So here we are looking at the Luminaire Lux yet again. I want to go ahead and show you guys how to remove some SMD components, and I also want to take a closer look and see where everything traces out here, because I think there's more going on with this than I initially thought. Let's go. This video is brought to you by these patrons. Thank you for your support. Alright, so here we are again with the Luminaire Lux. In an earlier video that I actually forgot to record, yet messing around with new equipment, I replaced this inductor with one of the spares, and it actually burned up again. So there's something else going on. I want to kind of take this off, and I also want to peel back some of the traces, figuratively speaking, to see what's connected where, and to find out if we can see if there's another component that is bad, because something is certainly going on. So I think the chain of events was a little bit more than meets the eye. So I'm going to go ahead and remove this from the quad, and we shall take a closer look at it underneath the microscope. So let's go ahead and do that. I got our 3 wires here. That's the only thing that's connecting it. And I'm just going to do this with the regular old soldering iron here. This is the FM 2027, and I'm using the the D1.2 chisel tip. So we're just going to pull these guys off real quick, just like that. Alright, so now this is liberated once again from this frame, which I am dying to get back together. I do have another flight controller, and I think I'm going to install that on it instead of trying to fix this to put it back, because I just want to work in quad at this point in time. I thought I'd have this fixed by now, and I don't. So okay, so here's a closer look at the flight controller and the parts in question here. So this guy is burned up again. I'm going to go ahead and pull this guy off. And then we're going to see if we can find out where the traces from this go. This over here, you can see this isn't actually burned. This is just flux. So that's all that is. But we're going to go ahead and take this part off and just see if we can figure out anything else. Because what I think is going on is one of these regulators has gone bad. Because our initial part right here, this capacitor had come loose, which fried this inductor. But I think something else happened. I think this came off, and one of these regulators went bad, and then that fried this. So when we replaced this, unfortunately I don't have that video. When I replaced this, it's still fried. So something else is bad. And I also want to check this resistor here, because this looks not good. I don't know if that melted or what happened. Let's see if we can take a closer look at that. It doesn't look too good to me. Let's see if we can fix our focus here for you. I mean, maybe it's all right, but let's see. If I put this on ohms, and these probes are freaking huge. Let's see if I can even get in there without touching anything else here. So I am getting a reading of 4.7 ohms. So I'm going to go ahead and say that's probably okay. Let me check this one here too. Oops. Because this is also a resistor right here. So let's see if this one is also, I'm getting a reading. This is 74.9 ohms. So I wonder, I should really check another one of these and see if they're the same or not. So I'm gonna just pop this guy right here on top, and we're way out of focus. I apologize for that. So this is a donor board. Okay, and right about there we're good. So those are the same resistors. So let's go ahead and take a look at those. And sorry if this moves around a little bit here. I do not have the this one tied down. So this is giving me 75 ohms, right? Well, yeah. And this one here, this is our 4.7. I can get that back in this visual here. And sorry about the focus here. I'm just trying to check this quick. 4.8. All right, so that original resistor in question, we'll go back to the original board here. This one's mine. So that resistor is still good. This one measures out to 4.7, and I forget the measurement of this one here, but they both match between both boards. So those are still good. So let's go ahead and dive in. Again, I want to pull this guy off, so let me grab a pair of grippers here. These are the CHP OODSAs. Can you even see that? Yeah, there's no reason to show you that. And what I'm going to do is I'm going to hit this with the hot air rework station. I'm going to put it at like 300 C and about 80 air and see if that is too much or not enough or what have you. So let's do that. And this is actually at 300 C air and 50 liters per minute. And I'm just going to go ahead and heat up the entire board here from a couple inches away. And then I'm going to go in and actually heat this guy. And I'm just going to kind of touch on it until it moves. We'll see the we'll see the flux start to kind of boil up a little bit. And we'll be able to pull it right off of there. If I can get my tweezers on it here. I might need a little bit more heat here, I think. No, there it goes. I can see it's moving. The left side of it came loose here. Right side, not so much. And this is taking way too long. As you can see, that left side is good. Right side, still not molten. There it goes. Okay. So that took too long. I think I need more air. We can. Well, I'm gonna clean that up with the soldering iron. So if we go in here with the D12, I'm just going to clean these pads up just a pinch. And as you can see, they're starting an ice cream cone there. We don't have much flux in there. So I'll grab a little bit from here. Oh, okay, that's not good. See that? We pulled that pad. That is not good. So until we learn how to fix a flight controller pad, we're kind of up the creek here with this flight controller. So that's not good. That is definitely not good. So if you know how to fix a pad, I'm trying to get this back in focus here for you. So if you know how to fix a pad, that's a significant problem. It's definitely a significant problem. So we know that's an issue, but let's carry on here, because I definitely want to see what else is going on here. So let's zoom out, and I'll fix the focus again. There has got to be something else here that's going on. So if I want to see if there's a trace that runs to this guy, because I don't know if you can see it, but it looks like there's evidence of it getting warm here. So let's hit that with, I'm going to put this on continuity. I don't know if you can hear that or not. I will let you know when we have continuity, if we do. So I want to check this guy from this pin here to, okay, so we have continuity there. So this guy here is the this is the 3-volt regulator then. So I want to see now if there's a connection from here to the 3-volt pad, just to verify that. So we got the 3-volt pad down here on the left. Can I get this all in screen for you? Yes, I can. I'm sorry, the left side is out of focus. I got the 3-volt pad there, and we got this guy here. So let me see if this guy has any continuity, and it does not. It doesn't mean it's not connected, but what it does mean is there's probably something elsewhere that this goes through that is not directly connected. So if we follow this guy, I can see trace that runs. This is actually very hard to see. Let's see if I can get in closer here. Okay, so we've got the trace off the 3-volt pad. Runs up this way. Does it actually run to this? It looks like it does run to this resistor. Okay, so it does run to this resistor. Looks like on this side here. And then it looks like we drop off and head to the other side. What is this resistor here? This one is involved too. Okay. All right, so it comes up here, goes across here, goes through this one, It flips to the other side. Looks like in 2 places. And then we go into this guy, and I think this is a crystal oscillator. I'm not certain. If you know, please let me know. But this whole resistor, this side goes into it here, this side goes into it here. And then we come out of it on the other side. We got this oh, what's going on with this guy? What is going on with that guy? That doesn't look like it's seated properly. Let's take a closer look there. I think we're all right. Sorry for the focus here temporarily. I want to kind of flip this board up and get a closer look at it from the side. And I know that's going to throw off the focus temporarily here. Come on, we're not quite going to make it. Okay, it does look like it's fine. That's a capacitor. Now, as far as I know, the trouble with checking capacitors on the board is they will tend to kind of work together and give you a different value than what they really are. And by the way, if you're ever wondering how I'm telling that this is a capacitor and that like this guy is a resistor, the ones that are in black are a resistor. Say, so that's a resistor, that's a resistor. And then these ones that are in brown, that's a capacitor. And just so I can show you one more component here, if they are like large and square like these guys, I think these guys are inductors. Like this guy here, all this is inductors. So we've got a resistor there, an inductor there, and a capacitor there. That's I mean, these big, they could be capacitors, but I'm pretty sure those are inductors. I could be wrong. So again, this is all a learning experience. So here we are. All right, so back to these guys. So we've traced 3-volt back to here. Let me see if I can get you better focus. Right about there. Okay. So we've got the 3 volts, the 3.3 volt right to here. Let's see what goes on. So we got a via right there, we got a via right there, and we've got a via right there. And I just wanted to check the, just to make sure. Interesting. Very interesting. We got no, is this a fried resistor? It is giving me a value, but it's not, let me actually put this on ohms, and we can actually test it to make sure that it is giving me a value here. 6.371. Yeah, 6.371K. So it is a value. I don't know if it matches that of a different one here. I'm going to assume this one is proper. Let's see if we can check this. And again, I apologize for bouncing back and forth here. I am now understanding why some people that use this setup, they do kind of like a live stream, because this is going to be hard to edit back and forth. So this guy is, oops, sorry about that, back on ohms. We want to check the bottom one here. What did I say that other one was? 6.7. So I'm getting 135 ohms. So I think, let's check this other one here. Come on, 129. So I think that other one is a problem on the other board. Wow. Let's zoom back in. So where it does look like it might be a problem, it might be a problem. The other issue now that I see is, where do the traces go from here? Because it almost looks like we got a large trace. Sorry, I'm like lost here. So we got a large trace here. It goes all the way around. I'm sorry, I'm getting off of it here, but here it goes. It goes underneath the luminaire, and it goes up to this guy here. So I apologize, I cannot check for continuity and show you both, but so I'm getting a value there. I just want continuity though, just so it's easier. I don't need to keep looking at that. So I'm not getting a continuity value, but I am getting a resistance value here, and that is 4.035K, and this should be about the same, 4.032K. Okay, so that is on that same circuit, which means, is this guy connected? It almost looks like it is. This is interesting to me. All right, so let's check. Are we getting anything there? 0.5. Yeah, so this is, yeah, so no, we're not getting much of anything here. So this comes up here, hits this guy, and then this is very hard to see where this guy goes from here. This looks like a separate trace here to this guy, but where's this guy go? here. Okay, so that goes to this one. So we're this way. And then we're coming, so it comes this way, back here. Okay, to this one. Oops. And then off to this one. Is this one connected? This one is not. This looks like it's something different. You can see here there's a line that runs underneath it and around it. So this guy tracks in kind of a C, comes up, and then comes over to this guy. And then I don't know what's going on here. Is this a direct connection? It is. So this is some kind of a loop here. Where do you go from here? So we got into here, into here. This is connected. This is connected. This trace runs underneath this inductor, I bet. So now the big question is, how do we get from here to the switcher here, the regulator? I don't see anything. I don't see anything that runs underneath it, or you know, where it would switch sides of the board or something. It's just like it loops back. Interesting. Well, let's see where this guy is. So the regulator in question is here. Oh, what is going on here? I have no idea what this is. But this is definitely connected, and you can see, so it comes over here, it goes into this, comes down here, and then switches sides of the board. And I'm also not getting continuity across this guy, which I feel like I should be. So that might be something. Might be something. Huh. Let's see if I can get in and test this guy here. Alright, so I am getting one line through that. Continuity there. What is going on with you guys? I'm getting nothing from you guys. And then this is another regulator here. And this guy, I'm not getting anything here. So I wonder, I don't know how to properly test these guys yet. I wonder if there's some issue with this guy and where it's fried itself or whatever. But again, this particular board, with that pad being pulled the way it is, I really don't trust moving forward on it as far as trying to fix it. But it's definitely kind of interesting taking a look at this, trying to figure out where everything goes. And again, I can only trace it back to here, and I don't see anything that could, oh, wait a minute. So this guy goes up and over here, and as you can see, there's a via here. But this is also connected to the 5-volt pad, so I don't think, why would the 5-volt and the 3-volt share this? Interesting. I'm gonna have to find a schematic and take a harder look at some of this stuff and see how it's interconnected, because the 5-volt and that 3-volt pad are somehow connected. I'm gonna check just the 5-volt to the 3-volt. It shouldn't be connected, and it is not. But yeah, I wonder if maybe what we've got going on here is this kind of smooths out our signal here for both the 5-volt and the 3-volt, and then it's dropped down for the 3-volt. You know, maybe this guy is the switcher here. That's giving us the 3-volt off the 5. It's really interesting, but I also feel like, no, that's just that's just encircling these pads. That's nothing. So those are getting, like this pad is getting from that via something from the other side. And then the same thing for this pad here, the DA is coming from the other side as well. So they don't look like they're connected here. But this, there's something going on here and then coming around this way. So somehow, yeah, I gotta find out what this guy is, and I gotta find out why this whole situation here is kind of looping around. But I think that's what's going on, is we're taking a 5-volt signal, smoothing it, and then splitting it between the 5-volt and the 3.3 volt. But yeah, something is going on, because everything's gonna get back to this guy somehow, and I'm not sure where that's happening, especially because like over here we've got this guy, which is right here. This is switching to the other side of the board. It's switching to the other side of the board over here. So yeah, I'm gonna have to take another look at this guy. But I mean, because of this disaster right here, pulling that pad, I think that's put an end to this board for good. So this will be a donor board. Unfortunately, it's got broken parts that we need to figure out what are. So I guess I could put an inductor here, remove this guy, and put a new one there, and try it. But yeah, it is what it is. These things happen, and this is a learning experience. So what do I think happened here? Why did we pull this pad? That was clearly, I think 300 might have been too hot, and I think 50 was probably not enough air. I think that's what happened here. We couldn't move the hot air quick enough, and we had too much hot air, so all we were doing is just heating one side where we weren't heating the other side. And we pulled the pad, I think because I had the tweezers on it, and I was pulling on it lightly. But you got to remember, when we're working this close to a board, you stand a chance to overexert pressures that you wouldn't otherwise. This has got something going on over here too. See how it's kind of burned? So this might be, is this flux? Yeah, that's flux on there, so that might be okay. All right, well, I really dislike not being able to fix things in a video, but that guy looks like garbage too, huh? But sometimes we are incapable of doing so, and again, this is a learning experience. This is just me showing you what I learn as I go, and we're not always going to be able to fix things here. So sometimes this is me reaching out to you guys. Maybe you know better than I do, but at the current moment, I am stumped as to let me zoom back out here. Sorry about that. Just so I can give you a overview of what we're looking at and how everything kind of seats. Because I know up close it's kind of hard to do. So what I'm looking at here is the regulator somehow starts over here, feeds through a couple of these resistors and capacitors, goes through the inductor that we pulled off here, goes down to this switching regulator, and then from this switching regulator somehow comes over to here. I don't know how. There might be a couple other components in the way. Over here, this smooths out the power, supplies 5 volts to the 5 volt, and then it comes down here, and then it's, this might be, this might have something to do with changing the 5 volt down to 3 volt. Then it basically comes down here and ends up as a 3 volt. Now, as you can see, there is right there, you can see that little via right there. This 3 volt, and it goes back, looks like it goes back up here and then goes over there. My guess is this via here is what's supplying the MPU with, if we, I'll just move that over here and show you on this one here. So if I flip this guy to match here, that's about right. So the via we're looking at is right about here. And that's somewhere in this vicinity. So that's probably what's powering our MPU. There it is right there. There's our via, and you can see it hits that pin right there. Let me move this over here so we can take a look at this. So it looks like it hits this bottom right lower pin here. So I'll have to take a look at this chip and see if that's the 3 volt in. So that's interesting. That's what I think is going on there. It'd be interesting if we can also trace that, because it looks like there's another trace here that runs through here, and I'm willing to bet that that runs somehow to the where is it here? It must be on the other side. The USB port. Oh, there it is. There it is. Okay, so I bet you it would make sense that we've got a trace somewhere down here that runs along here into this. So when we plug this in, this is powered also. So there's that. But you know, here we are. I hate leaving a video off like this unfinished. But you know, that's just kind of a look at what is going on one of these things. That's a look at how not to remove a component. Again, I'm still new to this stuff, so I reserve the right to screw up royally often. And then you guys get to see a good video where I screw up something that was already screwed up, that I'm going to screw up some more. So, you know, it is what it is. I hope you guys are entertained. I hope you're learning something. And again, if you know these parts better than I do, please chime in below. I reserve the right to be wrong. These guys, I can put a link in the description below. I just picked these up. They're not from Pololu, but they're Polus or something like that. They're magnetic bottom, and they got the nice little stuff so you don't scratch up your thing. And the way they work is they got a little rubber O-ring in there, and then you just back this guy off. You can put your board in there and then cinch it down. And I've just picked these up a couple weeks ago, and I happen to like them. They hold this board really well. I mean, this thing is not going anywhere. But you know, this is not a commercial for these guys. It's just something that I happen to pick up and I like, and I'm going to be using them from now on. So I'll probably do a video on these specifically soon. But anyway, they're here. I just wanted to show you. Just wanted to show you them. But anyway, yeah. So I think this is the death of this flight controller. Unless, you know, one of you, if you have a good idea how to fix pads, especially this one, it's big. It's still attached. If we can glue that down with something, if anybody has had good luck with anything, let me know, and we'll make that a video. We'll fix that. I don't know of anything offhand. I mean, you could try to super glue it or whatever, but it's got to handle high heat, so I don't know if that's gonna work. But anyway, yeah. So I apologize. We couldn't get this thing running, and we might not. I don't know. As I learn, I'm pretty sure we'll figure stuff out. But yeah. So just a little bit about what's going on too. I know a lot of you are dealing with the COVID-19 This isn't really a video about it, but I do have a lot of videos that I want to record inside on the computer, and unfortunately we're going to have to hold off on those for a while. I am having my 3D printers run 24/7 because I'm printing things for the local hospitals and donating them because they need some PPE equipment, and I have the ability, and I'm currently out of work, so I'm doing my part to help out, because what else am I going to do? My state is currently on lockdown, so we can't really go anywhere. My wife and I are both out of work, so it is what it is. We'll get through it. All this is temporary, but that's why I haven't been doing any indoor videos, because those things are just ripping lately, and I don't plan on stopping until I run out of filament and can't afford anymore. So yeah, there's that. I think not that I'm making much of anything on Patreon, but I think any proceeds from that I'll put towards new filament, and I'll continue printing parts for the hospitals and get that out. I'm also looking at masks and filters to do that. If some of you guys need help, if you need a mask or something like that, seriously, get at me in the comments below, and if I can get them figured out soon enough, maybe I'll print some for the community and give those away. I want people to be safe, and I know a lot of those things are hard to come by, and I know not everybody's got a 3D printer, so I'll do what I can. I can't help everybody, but I'll do what I can. So let me know in the comments below if you need some kind of help like that, or whatever, or you want me to point you to a specific mask or something. The ones that I'm looking at right now, the guy's actually lab testing filters, so it's kind of a big deal. So anyway, back to this. We will do more with it. I'm just not sure what and when, but that's what it is. So anyway, listen, I appreciate you guys watching. I hope you're learning as much as I am, or at least are entertained by it. And with that, if you haven't done it already, go ahead and punch that subscribe button, because you only get to do it once, and it's fun. And I'll catch you later. Peace.